Let's have a review of what a linear graph looks like, and you should be familiar with this equation y equals mx plus c. What we want to just refresh our memory about is what does the m do and what does the c do? What do those numbers mean in the whole equation? To do that, let's have a look at a graph here. Here's a graph and I've got y equals 1.6x plus 0.3. If I change this 1.6, and I've put some sliders in here, so if I change this value here, what it's doing is it's changing the gradient or the steepness of the line. Okay, this point here, this C, just moves the graph up and down, changing what we call the y-intercept, changing where it cuts the axis. Now let's have a look at the particular value. So if I stop here at C equals 3, it actually cuts the y-axis at the point 3. If I go down to -1, this line cuts the y-axis at -1. So in our equation, whatever number's on the end, the number by itself will tell you where the graph cuts the y-axis. The steepness, the gradient, will tell you how steep the graph is, whether it's positive, whether it's a negative gradient, which slopes back the other way. And it also tells you, let's have a look, if I've got a stop here at a gradient of 2, that's saying for every step across that I do, I need to go up 2 points. For every step across I go, I need to go up 2 points. Anywhere on the line, if I start, I go across 1, up 2, across 1, up 2. Let's change our gradient to 3, and you'll see that that step changes. If I start here, across 1, I go up 1, 2, 3. Across 1, up 1, 2, 3. So that's what the gradient and the y-intercept are all about. So putting it into here, changing that value of the m changes the gradient. And we know another word for gradient is the steepness. For this value here, the c, that changes what we call the y-intercept. And that's just where the line cuts the y-axis. If you know the gradient and you know the y-intercept, it's really quite simple to put the graph onto the axes. The converse of that is if you know what the graph looks like and you're asked to work out what the rule is. So let's have a look. It says here, for each of these following, state the gradient, the y-intercept, and then work out the rule. So for this, we need to know, first of all, we know our y-intercept, our c is 1. C is always the y-intercept. For the gradient, we need to know how to find the gradient. If you remember, gradient is rise over run. So how far up are you going? How far across? For every one step across, I'm going up 1. 1 step across, going up 1. 1 step across, I'm going up 1. So in this case, my gradient is also 1. So my equation is y equals 1x plus 1, or we could just write it as x plus 1 for that one. Let's have a look here. Y-intercept of 2. My gradient, I need to know how, every time I go across 1, how far up am I going? Across 1, how far up? So I've got a rise of 2, a run of 1. Using this equation, my gradient here, a rise of 2, a run of 1, my gradient is 2. Y-intercept is 2, gradient is 2, so y equals 2x plus 2. This third one here, my y-intercept is down here, so my y-intercept is minus 2. Now I need to think about every time I go across one step, I'm actually having to move down in order to hit my line. Let's find another spot. So here, if I go across one, I'm having to move down in order to fit my to find the line. So in this case, my gradient, I know it's going to be a negative gradient. If you remember what we did in that previous with the GeoGebra, you could see that the negative gradients always slope back this way. So to find the gradient of this, it's a little bit trickier. We just have to find 2 points that we know that this graph goes through. There's my triangle. A run of 1 and a rise of 1, 2, 3, 4. Is it 4? Negative 4. A run of 1, a rise of negative 4. Rise over run gives me a gradient of negative 4. So my equation is y equals negative 4x minus 2, because my y-intercept here is at minus 2. So any time you need to find the equation of a line, you've just got to find gradient, y-intercept, and put them together. We've already discussed that a positive gradient will slope this way, a negative gradient will always slope this way, but we can also have a zero gradient, and any line that is horizontal has a zero gradient. Any line that is vertical has an infinite gradient. To get the equation of these lines, you can see here that this line on the y-axis, our value was 2. It doesn't matter what's going on with the x, the y value is always 2. So that's just the equation. Anytime you've got a horizontal line, you've just got a y equals equation. Over here on the x, I'm at minus 3. Anywhere along here, the x value is minus 3. It doesn't matter what's going on with the y. So in this case, my equation here is x equals minus 3. Any vertical line just has an x equals equation.